Welcome, everybody, to DC Thursday. I'm Pete Soderling. I'm the founder of Data Council and the Data Community Fund, and I am pleased to be your guide through the crazy, vast, sprawling data ecosystem. And as you know, we bring you amazing guests every week, people who are influential in the world of data, data engineering, data science, analytics, AI research, etc. And today we have an amazing guest for you, no exception. I'm extremely pleased to welcome Raghu Murthy to the show. Raghu is the founder and CEO of Datacoral. Prior to that, he's worked at some amazing companies. He was EIR at Social Capital. He's been a PMC member for Apache Hive, an engineering leader at Bebop, which was acquired by Google, an engineering manager at Facebook, and also an engineer at Yahoo. Raghu also has a master's in computer science from Stanford. So Raghu, that's quite the list of accomplishments. Welcome to the show.
Thank you so much for having me, Pete. It's great to be here.
So I've been looking forward to this conversation for a couple of weeks because you're another one of these unique people who's sort of seen data from the very early days, back in the days when we called it big data, forgive the air quotes, but it seems like we've come a long way, in the last 15 or so years, and you've seen a lot of it. So I want to start at the beginning. How did you get interested in data originally? Like, what are some of the circumstances surrounding your early jobs with data?
Yeah, happy to share. I'll be definitely dating myself. So I started at Yahoo back in the year 2000, almost 21 years ago now. And the main reason for me to join Yahoo back then was to just work on systems. So I didn't have much of a background in databases or anything like that. I was actually more into compilers back then. And at Yahoo, the goal was to process large amounts of data by writing Unix programs. Because trying to load that data into Oracle and process the data there was way too expensive. So from there, we kind of graduated to building a SQL parser that would essentially generate the configuration for these Unix programs. And the goal was to run these Unix programs on multiple machines that all had a single NFS mounted NetApp filer with all the data. So it was kind of this duct taped, glued together system that actually did pretty well. We had, I think, close to 100 terabytes of data at around 2006 or so, 2006 or 2007. And that's kind of how I got started into data. Didn't really know much about databases. I actually went to grad school after I was at Yahoo, and that's when I realized that how parallel databases were built. And turns out we had actually solved some of the same problems in very similar ways. So it's just being a software engineer and a systems designer, and you end up solving these problems. So that was my start.
And when did Hive emerge on the scene at Yahoo?
So Hive actually started off at Facebook, right? So I joined Facebook in 2008. And they were just about getting started working on Hive. So this time around, the problem was similar: process large amounts of data because Oracle was too expensive, try to find an alternative. And this time around, the alternative was Hadoop. So at Facebook, people had gotten started already on working on Hadoop, and then realized that writing these MapReduce programs was kind of hard. So they were writing a SQL parser that would essentially generate these MapReduce jobs, or the specifications for the MapReduce jobs. And I joined the initial team that built an open sourced Hive at Facebook. And so when I joined Facebook, they had, as you can imagine, a smaller amount of data than Yahoo. So I think Facebook was at 50 terabytes or so, about half of what Yahoo was back then.
Okay.
But yeah, so clearly at Facebook, it grew dramatically. And over a period of about 5 years, it went to hundreds of petabytes of data across multiple data centers and so on. So that was a kind of a different trajectory than what I'd seen at Yahoo for sure.
Got it. And so I forget, were you working on Hadoop at Yahoo? And did that sort of
No,
inform your Hive work? No, you weren't. You weren't on
no.
the Hadoop team.
Yeah, yeah. So I
Mm-hmm.
was working on data before it was called big data, I guess. So
Mm-hmm.
so there's like a separate team that had gotten started on Hadoop.
Mm.
Uh, but I was in the data team working on this kind of Unix based data processing kind of systems. And Hadoop, I think, was started more on the search team
Mm.
at Yahoo.
Got it. Well, then, since you ended up at Facebook, and that was sort of the introduction to the Hive experience, talk to us a little bit about how Hive was used at Facebook and some lessons that you learned over those years.
Yeah, so the great thing about the way Hive was built at Facebook was the general kind of movement towards democratizing data, right? So trying to get pretty much every part of the company to be able to leverage data and not build these or not have these kind of centralized teams that were
Mm.
in some sense kind of controlling access to the data. And because that
Mm.
was the traditional kind of way of doing things back then. So kind of called it like the priest model, right? So to get to guard your data, you have to
Mm-hmm.
go through the
Mm-hmm.
priest, right? But the democratization of data meant that there were now these systems and tools that were available for everybody in the company to be able to do whatever they wanted to do with the data. It was an open system. There were no restrictions or kind of constraints on what people could do with their own data. So there was, of course, kind of security around kind of sensitive data and so on. It might be hard to believe, but even back then at Facebook,
Mm-hmm.
people were worried about kind of the sensitive data that was sitting in the data systems, and very few people could access, for example, like the payment kind of information and stuff like that. It was all kind of cordoned off. But this general movement to have everybody in the company to become data aware was the impetus for Hive and pretty much every layer that we built on top of Hive, to including ways to build data pipelines to be able to kind of ingest data without having to write too much code, being able to build dashboards. All of that stuff was built by a central team, but pretty much every product team, every engineer knew how to interface with the data without really having
Mm-hmm.
to jump through too many hoops.
Mm-hmm. Mm-hmm. Got it. And where was Facebook at in its data infrastructure when you ended up leaving?
So I left the data team in 2013. So over a period of 5 years, went from 50 terabytes to probably like 150 or 200 petabytes of managed storage across
Mm.
multiple data centers. In fact, the last project that I did at in the data team was to make it so that data could actually sit in multiple data centers. So we had one giant Hadoop cluster, and we keep running out of space, and we had to keep moving these clusters from one data center to another. And we reached a point where we could not build a data center big enough to hold all the data.
Mm.
So we had to kind of mid flight, like you couldn't just shut down the cluster, right? So we did this kind of intense project that made it so that we could actually split data and move it into different data centers and different Hadoop clusters. But of course, people had gotten used to joining data from different kinds of sources. So we built like a pretty efficient kind of replication and kind of like a subscription model for
Mm.
not small amount, like terabytes of data. So people would subscribe to certain tables, and there'd be like petabytes of data moving between data centers
Mm.
because to support analytics that would then happen in those clusters in those data centers.
Mm.
So that allowed us to kind of get to quote unquote infinite scale. I'm sure in the past, I guess, 8 years or so, they would have gone to much more sophisticated systems. But that evolution for me, or being part of it and being kind of so closely uh, kind of associated with it, was really cool.
Mm-hmm. Yeah, that's great. And it obviously inspired you to build some new systems for the world yourself that you thought the world needed. And so you're one of the few engineers I know who became an EIR. So I'm kind of curious to learn about that. I guess Bebop was sort of probably sandwiched in there somewhere, but ultimately you became an EIR. So I'm really curious to hear like how that transition happened and what the motivation was.
Yeah, so after Bebop, I spent about a year there. I was just kind of sitting at home, and the folks at Social Capital, uh, who I'd worked with in the past at Facebook, they just told me if I was interested in just learning about what is happening and essentially treat Social Capital as like a parking lot for whatever I wanted to do
Mm-hmm.
next. And they said EIR, and I told them, like, look, I don't have any ambition to start a company yet, so I'm not really an entrepreneur. So then they said, okay, it's engineer in residence then, so still EIR, but that's kind of how I
I
kind of
like
ended
that.
up joining Social Capital.
Mm-hmm. Mm-hmm. And so tell us a little bit about that experience. Like, what did you do on a daily basis, and what were you interested in at the time? And I mean, I think I know kind of where the story ended,
Mhm.
but I'm curious to hear like what was sort of transpired, what transpired in your mind as you were trying to figure out what an engineer in residence was supposed to do.
Yeah, so my goal there was to just drink from the fire hose, right? So Social Capital had incredible people and some amazing companies coming in talking to them. And I was just uh, amazed by all the different things. I mean, the thing about Social Capital was that they were looking at all kinds of verticals as well, right? Like frontier
Mm,
technologies or like uh, healthcare or enterprise, like all over the place. And one common theme was the fact that everybody had data that they wanted to work with, and they knew what they wanted to do with the data, but then they were kind of figuring out how best to kind of do that. And turns out everybody had to hire engineers to leverage their data.
mm,
So I grew up in my career having built all the systems that we used, right? These companies like Yahoo and Facebook, they had immense resources to invest in engineers like us to be able to build all the systems because there's nothing out there. And the more I talked to these companies, these were fairly small companies. Uh, they were really successful companies, but they're probably not even hit this. They never hit the scale of like a Facebook
mm,
in their
mm-hmm,
entire lifetime, even though they became really big. And this is also around the same time that clearly the clouds were becoming more popular, and
mm-hmm,
specifically serverless technologies were becoming popular. And my take was that because there were the clouds and all of these serverless technologies, the complexity of building a system or building a data infrastructure stack had to be like much lower than the complexity that we had to deal with, both because there were primitives that the clouds offered and the fact that
mm-hmm,
the data volumes were not that high. And the more that I started pulling on that thread, the more I realized that specifically with serverless technologies, it might be possible to build quote unquote a push button data infrastructure stack
mm,
where you don't really need engineering to set things up. You can have an analyst or a data scientist who'd be able to kind of fend for themselves. As long as they knew SQL, it should be possible
mm,
for there to be a product that would help them kind of do their job without really having to deal with the underlying systems or even the plumbing of the data
mm,
pipelines that were needed.
mm,
Right?
mm,
So that kind of got me thinking about kind of what it takes to kind of build this kind of a system. And the first thing that I did about it is not actually make a deck or anything. I started writing code. Um, and some of Social Capital's portfolio companies who I was talking to, I was telling them that I was building this. And they said that if I built it, they would use it.
mm, mm.
And
And the idea was basically to take the engineering out of data engineering, so to speak.
yeah, engineering, the complexity of engineering out of data in general,
Mm-hmm.
right? So
Mm-hmm.
I'd seen so many of these companies that had data scientists or data analysts who were kind of basically stuck writing scripts and kind of pipelines, and they wanted to analyze data, but then instead they were maintaining these pipelines. And that was taking up so much of their time that their analytics kind of productivity kind of was decreasing.
Mm-hmm.
So yeah, so when I said that I was going to build something like this, some of these companies said they would use it, and then I definitely have to blame the folks at Social Capital who said, "Hey, looks like there's a company here. Here's a check." And I was like, "Okay, I'm just building this because I think something like this should exist." But that is kind of what caused me to, I guess, start the company.
Wow.
But yeah, it's been an amazing journey.
So that became that obviously the company became Datacoral, and now you have many more customers, and you've been building serverless-oriented, cloud-based data infrastructure for the last few years.
Yep, that's right.
Yeah, that's great. And what was the response from the early customers? Like, I'm curious as to, is there a learning or a lesson or a story from some of the early customer days that you can share with our audience?
Yeah, so in the early days, most companies, they started off saying that if I have to get serious with data, I need data engineers. And in fact, we did talk to a few companies who had data scientists who had built out these kind of pipelines, who basically told me, yeah, I think I've got it covered. I don't think I need a product that will solve this problem for me. But then 6 months later, they kind of came back and said, well, maybe we need something that'll actually ease this pain of having to maintain data pipelines. And we don't really have a budget, or we wouldn't want to spend our kind of precious engineering resources on this. So is there something that you could do to for us to skip the step of first hiring an engineer who would then go and build stuff, right? So that was, we saw this happen quite a bit with a lot of the initial companies that we talked to. And then as we started providing our own product and our product matured, we started finding that people in these companies could actually grow their data teams with mostly data analysts and data scientists. And they would have maybe data engineers that would come in mostly to provide some of the tooling that some of these teams needed for their kind of CI/CD pipelines and whatnot. But for the data processing itself, many of these companies were able to just rely on our product and our the data integrations, the data transformation, the integrated data transformations as well, to build like pretty sophisticated pipelines that that they would otherwise have to spend quite a bit of engineering on. So the the most heartening thing for me to hear is when the data teams say that they're able to punch above their weight level in terms of supporting multiple business units or multiple departments with like a really small team, because they don't have to worry about building and managing data pipelines.
Well, I feel like, from having known you for the last 3 years and watching Datacoral and the product evolve, I feel like you were very early again, not surprisingly, in this sort of modern ETL pipeline stack, because I think you were talking about ingest and transform and these kinds of terms. It feels like before they became industry standard. Like, I don't know exactly when Fivetrans started, and DBT probably started in 2017 or so. But I kind of feel like you had pioneered some of these terms, if not the terms themselves, at least the concepts in your early plumbing that you had built, and the building blocks that became Datacoral. Talk to us a little bit about how you saw the sort of design patterns and what some of the key principles were of the Datacoral system.
Yeah, so when I got started, there were a few data integration companies. I mean, of course, you had the traditional companies like Informatica and so on. I mean, they've been around forever. My take was to make two things. One is the fact that being cloud native means that you can move a lot faster, and you can actually help companies that are cloud native as well. So if companies were born in the cloud, they don't want to use any of these kind of traditional kind of systems that were much more fully featured and so on. So there are kind of two parts to how I was thinking about both what we are building in terms of the system, as well as the terms that we're talking about, right? The notion of kind of ingest, transform, and publish is kind of what we called it. And in fact, we call transforms materialized views because that is what we had generalized the concept around. So the two parts were, one, building a system that's cloud native, that's serverless, that would allow for the software to actually be deployed in the end customer VPC. So the software would be deployed in the cloud. So this would be not a multi-tenant SaaS kind of offering that was kind of the norm, but instead the software would be running in the customer's cloud, which meant that data would never leave their control. So that was one of the big things for me, and I'll kind of get more talk more about data security in a little bit. So that was the serverless part, and then the other part was on the data flow itself, like the ingest, transform, and publish. So this is just based on my experience having built these systems in the past, right? So there is typically only three things that you're trying to do with your data. You're moving it, or you're transforming it. It doesn't matter how complicated your transformations were. It's still kind of you might be running SQL queries to transform it. You might be even building machine learned models. You might be making inference calls. All of that are essentially data transformations. And those became our primitives as well. Like in terms of the data flow, there was the ingest, there was the transform, or what we call materialized views, and then there was the publish. And I guess nowadays publish is being called reverse ETL. That's kind of the newer term that's been happening probably in the past year or so. So yeah, so that's kind of how I started kind of thinking about Datacoral. It had to be end-to-end, and it had to provide these capabilities. So there was the serverless implementation, and then in terms of providing this end-to-end capabilities, it was about having a metadata first approach to building the data flow kind of primitives. So if you have these tools that are doing their own orchestration and have their own metadata that are performing different parts of your data flow, then trying to stitch them together, work with them, debug problems becomes really hard. So again, this was something that I kind of experienced in the past, having seen the challenges of systems getting really complicated if you have too many moving parts without like the central brain, if you will. So we started with that. We said, okay, we are going to go metadata first. And then that also allowed our data flow functionality of ingest, transform, or publish to become a lot more lightweight. And that ties into those kind of primitives becoming serverless as well, right? So because serverless typically is meant, at least at that point, was meant for like pretty lightweight operations. So my take was, how do we marry the two, the metadata first architecture and serverless? And that was a thread that we have been, I guess, pulling over the years. And we've been able to show that it is actually possible. And we have, in fact, the way I look at it is we have a reference implementation. Clearly, there'll be multiple kind of iterations on top of it that we'll be working on. And I hope kind of the industry also kind of looks at seriously as well.
And so was the serverless architectural design decision, was that well received by customers at the time, or was most of that just hidden sort of in the background and it was just your sort of implementation decision? Did that have material impact on customers' interest in the product? Because it was sort of very early in serverless as well,
Yeah,
as
exactly.
you mentioned.
Yeah, so people didn't really care about serverless, but they did care about the fact that the software was deployed in their VPC. The fact that data was not leaving their environment. So companies that would otherwise decide to build something in-house because they didn't want to use a SaaS service and pipe their data through those systems. So those folks ended up being attracted to our architecture, because we could, it's not just through compliance that we were telling them that, hey, your data is secure. We are able to prove to them that the data is not leaving their environment and that
Mm-hmm.
their data is encrypted using their keys.
Mm-hmm.
So that means that even though we were able to provide a managed service, so they didn't have to do any of the monitoring or anything like that, right? We were able to provide SLAs on the data itself, the
Mm-hmm.
data freshness and so on. We could prove to them that we couldn't see their data. So that was kind of uh, the thing that attracted some of our
Mm-hmm.
early customers who didn't
Mm-hmm.
really understand the serverless part of it.
Yep, got it. You also mentioned metadata. Obviously, metadata is becoming kind of a hot topic
Mhm.
today.
Right.
What manifestation did your metadata architecture take? Was this something that you rolled your own? Did you use any open source tools, or how did you sort of run the metadata management piece of the product?
Yeah. So nowadays, metadata uh, as a concept, or as kind of the thing in the industry, has kind of become fairly popular, and as its scope has increased. Is kind of how I put it.
Mm,
Our focus on metadata has been about operational metadata. And that means it's about having your orchestration be driven by your metadata rather than by people writing code or programs, right?
mm,
And I'm happy to kind of get into a little bit of detail on that. Um, in terms of when you say what is metadata first, um, the idea is that if each component of your data flow is publishing information, it's of course kind of moving data or transforming data, but it is also updating a centralized kind of metadata layer. And in addition to that, you have your orchestration that is driven by that metadata. So what that means is that, let's say there is a connector that is pulling data from a data source and writing to a data warehouse. It is not only writing data to the metadata to the warehouse, but it is also publishing an event into, or publishing to the metadata layer,
mm-hmm,
an event that says, hey, uh, let's say this batch processing, here is a batch of data that got updated
mm-hmm,
in the warehouse. Now, if orchestration has to rely on that event to trigger something downstream, what you need is a data dependency kind of graph, or the DAG, right?
mm-hmm,
So we made it so that the metadata, the operational metadata, included the data dependencies as well.
mm,
So what that means is that when a new batch of data got written to a data warehouse, the orchestration would then figure out what is downstream of that particular batch of data that just came in.
mm-hmm,
And because the orchestration did the dependency management, it could then trigger the transformations. For example, when all the input data for a particular transformation was updated,
mm-hmm,
there was no explicit orchestration that needed to have been built out using a tool like Airflow or something like that.
mm-hmm,
Instead, people would just write a SQL query, right? That query would get compiled, and the metadata would now have the data dependency. So this query, which is a transformation, depends on these tables. And that's just the from clause of a SQL query, of course.
mm-hmm,
And once you have that information in your metadata, now the orchestration is essentially doing a reverse lookup, if you will. So every time a table gets updated, it figures out what are the transformations that are dependent on that particular table. And then each transformation has multiple dependencies. So once all the dependencies are met, then the transformation can get triggered.
mm,
So you have this really lightweight event-driven orchestration
mm,
where even the orchestration engine itself, or like the orchestration itself, can be serverless,
mm,
right? Because it is only operating on like a small, uh, like local area of the DAG. It doesn't
mm,
have to actually load the entire DAG into
mm-hmm,
memory, or
mm-hmm,
like keep it
mm-hmm,
around or whatever. The orchestration
mm,
itself is serverless. It's event driven. There's an event that comes up, orchestration comes in, figures out what should run, triggers them. Each of those things that it triggers are also serverless. But then once it triggers them, the orchestration goes away. Whatever runs does its thing, emits an event, which then triggers orchestration again. So that just dramatically simplifies the entire architecture. Right?
Yeah, and it also makes it sort of ready to go on a serverless infrastructure, which is not something that many data engineers have ever explored before.
Right, exactly. And one last thing I'll add about this is that because the orchestration is dependent on these data dependencies, you are now forced to keep the metadata clean, right? So this is operational metadata now. So that means that by design, the metadata that you can then view, like people talk about kind of the data observability, or like being able to have like a single pane of glass for all of your data flows and so on. Instead of single pane of glass being something that is accumulating information from multiple tools and trying to somehow glom them together because there are impedance mismatches between different tools. Here, the shared metadata layer offers like just looking at that metadata is already a single pane of glass for your entire data flow. Right? So that the metadata quality as such is not an afterthought. It is actually built into the system.
Yeah, I love it. That's a super fascinating design. I want to ask you about change data capture, because I know that that's something that you've also gotten interested in recently, and obviously fits into the Datacoral ecosystem, which I want you to tell us about. But before we talk about the technical ins and outs, talk to me about how you got excited about change data capture and the customer conversations you had that sort of made you aware that it was a need. I'm just curious how that came to the surface.
Yeah, so for the first couple of years that we were in business, we were just focused on this kind of end-to-end flow. We were building data integrations, which were pulling data from different sources like databases or APIs and file systems and so on. And then we were also kind of doing the transformation and the publish side too. Some of our customers said, hey, we like your SQL-based connectors that are running SQL queries in the source database and are able to kind of integrate that data into your data warehouse. But we want to be able to handle hard deletes efficiently. So one of the challenges with like a SQL-based connector is that when you run a query on a table to say, give me all the rows that changed since the last time I ran this query, then if you're doing soft deletes, it's fine in an application. But if you're doing hard deletes, that means the rows go away.
The rows aren't there.
Yeah, exactly. So now your SQL-based kind of query doesn't know that the row went away, right? So now you have your data warehouse that keeps accumulating all of these deleted rows because there's nothing that said that a row was deleted. Now, there are ways to, of course, solve this problem, which is if the table has primary keys, then every so often you fetch all the primary keys of a table. You don't fetch the entire data, but you fetch only the primary keys. And then you do like a join on the destination to then remove all the rows where the primary keys didn't show up, right? But as you can imagine, it's a fairly expensive operation. And in fact, some of our early customers did that. But then when these deletes became kind of, or handling these hard deletes became expensive, they're like, okay, there is this thing called CDC that we have known about, but we never really worked on because we already had enough things to do. So that became one of the requirements. And then the second thing that came about was people wanted to know exactly how their data had changed. So if you have a SQL-based connector, you would run queries every so often, and you would get the updated rows. But between your two fetches, if a single row had been updated like 10 times, you have no visibility into all of those changes. You only get kind of like this snapshot, right? So you get time 1 and time 10. So all the changes between time 1 and time 10 are lost. So again, doing a log-based CDC became important because of that. So databases have this thing called as a write-ahead log, which is part of their own kind of replication mechanisms, or DR, or disaster recovery kind of mechanisms. And CDC connectors were essentially a way to read these change logs, or the write-ahead logs, from the databases, and then apply those logs into the destination warehouse. And we found that there were a bunch of advantages to doing this. One, it's a lot less expensive to just read the write-ahead log from the database instead of actually running queries on the database, right? Because if you're running queries, there's more load on the database. We had figured out a way to reduce the load by paginating and stuff like that, but definitely a log-based CDC approach would be a lot lower footprint. And we had this ability to now handle hard deletes, to be able to provide full visibility into all the changes to a given row, or given set of rows in the destination, if there was a need for that. So we set about building a CDC connector for these databases. So this was also just about the time that Postgres, specifically on AWS, came out with logical decoding, right? So that was also not something like these write-ahead logs are written for the consumption by the same database, right? Not by anyone else, because it was meant for replication. MySQL was much better. It had bin logs that, in fact, back in Facebook over 10 years ago, we were kind of talking about, and we had built systems to read the bin logs. And we were already doing those kinds of things back then. But with Postgres, logical decoding was kind of something new. And we set about building a CDC connector because we had this end-to-end flow. So when you think about what it means to build CDC, a CDC connector, turns out it's actually more complicated than any other data integration that you would have to build. You need the ingest capability, you need the transform capability, because you're just getting the changes and then you're applying the changes onto the destination. So you need the transform capability as well. So because we had those primitives, we set about building these CDC connectors. And then we started finding that you can provide more guarantees. You can, in fact, provide much more robust data freshness guarantees. You can provide checksum based kind of guarantees to say that the data was actually replicated with high fidelity. So that is when we got really excited about CDC. And so our question was, okay, why is it not possible for all data integrations to be CDC? Right, and that's the reason I kind of wrote that post in Towards Data Science. So as we kind of looked at what it means to build CDC, clearly production databases that have been around are much more amenable to CDC because they write out this write-ahead log that can be read. But other systems, whether they're APIs or even file systems, so it's actually a hard thing to kind of build right now. But we believe that CDC raises the bar for what a data integration can and should be doing.
I just published, I posted that blog post in the YouTube chat so that folks can find it. In case they're watching a replay of this and don't see the chat, the title of the post is All Data Integrations Should Use Change Data Capture by Raghu from April 2021. It's on Towards Data Science on Medium. Well, that's fascinating, Raghu, and it sort of makes sense that when you're talking about sort of the other benefits you get from having a fully CDC compliant system in terms of data freshness, and it sort of can improve your SLAs in other ways. I guess that's an interesting, maybe sort of unexpected side effect of this process that you discovered.
Yeah, so the more we dug into building really robust CDC connectors, we realized that clearly there are kind of specialized CDC players in the market. But in terms of data integrations, our thinking was that we like there are already some products that offer, they don't really call it CDC, but they offer this whole event-based kind of approach to kind of fetching data. Like Stripe is a great example, where they have APIs where you can fetch the individual objects like invoices and whatever else, but they also have an API for events. So that allows us, and so we read those events. So these events are generated every time any object is changed. So this starts looking a lot more like a write-ahead log in a database, right? So we have been able to kind of leverage that in Stripe. We are also kind of hoping that all of these other tools that provide APIs to fetch or access data in bulk, if they start offering these kind of event streams instead, then it makes building a CDC connector a lot easier, or forget it, easier. It actually makes building a CDC connector possible.
So we have a question from Daniel about this. I think it's about metadata in the CDC context. Raghu, let me read this to you and see what your thoughts are. He's asking, can you talk about the metadata layer in this context? Query Q accesses table A at noon, then it accesses table B at 1 p.m., which accesses A at 1 p.m., which had been updated. That's a bit of a puzzle. Do you understand where Daniel's going with that?
I'm guessing. So let me tell you what I understand from the question, and maybe I need to clarify where CDC is happening, right? And where the transformations are happening. So when you talk about queries that are running at different points in time, from our kind of point of view, or from like what we see, is transformations that are running in the destination warehouse. And that is what we orchestrate and drive. So when we are doing CDC, we are actually batching up the changes that are coming in before we load that into the destination warehouse. We are not doing like row by row updates of the destination warehouse too, because that would just be really inefficient. Because data warehouses are not really meant to be doing kind of in-place updates of like individual rows, right? So we actually perform batch operations in the destination, right, which is the warehouse. Now, when we talk about the event stream or like the write-ahead log that's coming in, it has all the information, right? So it has all the changes that have happened since the last time we fetched, or we actually fetch it in a stream. So we keep fetching it and we kind of cut these batches that then get applied to all the tables in the destination. So there is a single stream that is coming in with changes from all the tables in the source, because that's how write-ahead logs work. And that's also like a lower footprint way of building a CDC connector. You can actually have separate write-ahead logs that you can read from for each of the tables, and that just adds more load to the source database. So what we do is there's a single stream that is coming in with changes from all the tables. We cut that into these micro batches, so it could be every minute or 5 minutes or whatever, depending on what the customer's requirements are. And then we apply the changes to the destination tables in batches. Once that happens, we have the use case is still analytics, right? We are not building streaming systems here with Datacoral. We have converted the streaming kind of system into a micro batch oriented kind of flow. And the metadata, I'm trying to answer the question that came in. The metadata is about these small batches of data that are getting updated into the destination tables. And that drives the orchestration, right? So our orchestration is, of course, also driving the updates to the table. So there's one kind of process or one container that's kind of reading all of these, the stream of data and kind of cutting it into batches. Once that each batch generates an event that then triggers the transformation, that then triggers the orchestration, which will then kind of do the rest of this, the data flow for that batch of data. So a query that runs at a different point in time, the actually has all the changes until that point in time. The one other nuance here, and this can get into a lot of depth, is that these batches are of data that are coming in are mostly arrival time based. So the idea is that when you have a streaming system, the most robust way of ingesting that streaming data is to just and convert it into batches, is to create batches based on arrival time. And then you apply these batches to the destination tables, which is also kind of arrival time. And then at some point, you have to decide that all the data for a particular day is done, right? Because this is kind of like close of books or high watermark or things like that that people have kind of talked about. We have incorporated that into our orchestration too. So we know based on the metadata of each batch, what is the timestamp in that latest timestamp in that batch. And when that timestamp crosses the high watermark, we know that all data for a particular time period has been collected, which then drives something downstream. Right? And from that point onwards, the batching as such is more data time-based rather than arrival time-based.
Got it.
Hopefully that made sense. We'll also kind of write about it.
Yeah, I think so. Daniel just wanted to clarify that he's talking about a fairly common race condition. And so it seems to me like based on this batching, the time windows of the batching that you articulated, Raghu, if the query happens sort of after the CDC batches come in, then everything would be fine. If the query is sort of, happening before the micro batches come in, then perhaps it wouldn't be caught. But it seems to be, it's sort of about the amount of time in this windowing that the CDC batches come in, if that makes sense.
Yeah, actually that problem that Daniel talked about is literally solved by our data-driven orchestration. If you write that query as a transformation that is within our system, it is orchestrated automatically. So what that means is that the query will not run until that batch has been applied to the table. Right? See, that's the beauty of having this event-driven orchestration, right?
This is how the event-driven orchestration and the CDC actually work together. I knew there was some connection somewhere that we were going to uncover.
Yeah. So the metadata-driven kind of orchestration, or like the metadata-first architecture, meant that it was going to be data-driven orchestration, and that is the primitive that we have used to build the CDC connectors. So it naturally kind of solves the problem of being able to write these transformations or these queries that you can then register within our kind of metadata, and our orchestration kind of picks that up from our metadata. That query doesn't even run until the batch has been applied.
Got it. Yeah, that makes sense. So moving on, Raghu, I just wanted to ask you, like, what are some of the pitfalls of folks trying to roll their own CDC implementations, right? There's some open source tools out there. There's Debezium, which I'm starting to hear a little bit more about these days. Do you see companies have success in trying to implement these things on their own, or what sort of advice would you give folks who are thinking about going one way or the other?
Yeah, so we talked about the advantages of CDC, right? So if those advantages actually make sense and people actually want it, at this point in time, they'll have to bear the cost, so to speak, of putting together a CDC solution. Our goal within Datacoral, and I think what is going to happen even in the industry overall, is it's the barrier to entry for CDC will lower quite a bit. And then at probably in like a couple of years or whatever, like people won't even know about the complexities of CDC, because a lot of systems would have already kind of simplified how CDC works. So now companies have a few options, right? So there are pretty sophisticated CDC solutions tend to be expensive. They've been around for a while. You can kind of go for that, or you can go for these kind of open source tools like Debezium that do take up some engineering to set up and also keep it working. There are other tools that are other data integration providers that also offer CDC kind of capabilities, but they have if they are SaaS, then of course they have uh, the property that data is flowing through their systems before kind of coming back to your warehouse. You may or may not kind of want that. And of course, I'll also kind of mention Datacoral, because we have built our own kind of CDC connector as well. It does. So nowadays, what we are hearing people say is that they would like CDC. They think it's like any other data integration, but once they start getting into it, they feel like it's a deceptively hard problem to solve. So we have been working pretty hard to make that easier. People shouldn't really have to worry about all of the underlying kind of moving parts to get like a robust CDC solution. And I think the industry overall will also kind of make that happen.
Great. Yeah, that makes sense. Hopefully some of the complexity will be abstracted away by tooling, smartly designed systems like Datacoral and others, as you've mentioned, and folks can start to capture the value of this in their own systems without hiring an army of data engineers, which we talked about earlier. So Raghu, as we wrap up, I just wanted to ask you, you spent so much time in the data ecosystem. Are there any particular areas of data that you're excited about on the infrastructure level that you sort of see emerging or consolidating, or people talking about? I'm just curious as to like what's on the horizon for you and what you're excited to track going forward.
Yeah, so I think we covered a couple of things at least that I'm excited about. We are talking more about it. We are seeing that there is a lot of conversations in the industry as well. One is the metadata first architecture, which we believe reduces the complexity of building a data stack. We've written a little bit about that as well. So I think there'll be more that will happen in that area. And of course, the second one is CDC to become the norm for all data integrations rather than just the specialized kind of the database integrations, if you will. So I think these are the two things or two threads that we'll keep kind of pulling on. That's what is kind of exciting for us as well as we are kind of building on it. And I'm also seeing that in the industry, there was this kind of phase where there were multiple tools. So there's always like a consolidation phase that happens, and there is this kind of expansion phase where people end up building specialized kind of solutions for each part of whatever functionality that they want. Then they realize that, oh, there are now too many moving parts, and there is a split brain problem. There's metadata that's kind of split across multiple tools, so now we need to consolidate. So I believe that in the next few years, we'll start seeing more of this consolidation happening, where companies just don't want to kind of deal with multiple tools or not deal with multiple tools. Even though there are multiple tools, they want those tools to play nice with each other. And our way of thinking about it is they should all have the same shared metadata layer. So I think that is where the industry will move, where people want more consolidation now. Earlier, it was about kind of breaking off from the central tools like Informatica and building just the ingest or just the transform. Or So we'll get into this hybrid where there'll be like a common metadata layer, but then there'll be scope for multiple tools to come in and do their kind of best on their part of their functionality. But then the metadata layer is the same, so management becomes easier.
Yeah, but still be part of a unified system through the metadata layer. Right. Yeah. Awesome. Well, yeah, you're reinforcing great things that we've talked about here on DC Thursdays as well. So it's great to hear that we're on the right track. And we really appreciate you sharing your experience with us today, Raghu. It's been great to catch up as always. I always enjoy our conversations, and and I learn a lot from listening to you. So thanks for all your investment in the data community so far. Where can people find you if they want more information about Datacoral, or if they want to ask you questions about other advanced architectures that they might want to pick your brain on?
Yeah, so you can learn more about Datacoral at datacoral.com, and you can reach me at raghu@datacoral.co. And thank you so much for having me here. I've always enjoyed our conversations, and yeah, I hope this was useful as well.
Yeah, thank you. It's been super useful for the community, and I look forward to seeing you in person soon.
Thanks. Take care.
So for listeners, I just wanted to mention that we have several more episodes already lined up for DC Thursday. Next Thursday on May 20th, please join us for a talk with Boris Jabez from Census on operational analytics. Raghu and I briefly touched on the reverse ETL category today, and so Boris is the co-founder of Census, and we'll have some interesting things to say on that topic. Also, don't forget to subscribe to the Data Council channel. Hit the bell icon so that you get notifications when we go live next time. And don't forget, you can also find all the previous DC Thursdays in our playlist right here on YouTube. So thanks, everyone. Look forward to